In November 2023, NASA's James Webb Space Telescope observed a massive cluster of galaxies named MACS J0138.0-2155. In addition to warping and magnifying the distant galaxy, the gravitational lensing effect caused by MACS J0138 produces 5 different images of MRG M0138. In 2019, astronomers announced the surprising find that a stellar explosion, or supernova, had occurred within MRG M0138, as seen in images from NASA's Hubble Space Telescope taken in 2016. When another group of astronomers examined the 2023 Webb images, they were astonished to find that 7 years later, the same galaxy is home to a second supernova. Justin Purell, NASA Einstein Fellow at the Space Telescope Science Institute and Andrew Newman Staff Astronomer at the observatories of the Carnegie Institution for Science, tell us more about this first time that 2 gravitationally lensed supernovae were found in the same galaxy. James Webb Space Telescope has spotted a multiply image supernova in a distant galaxy designated MRG M0138. 2 images of the supernova are seen in the Webb NIR-CAM image, but an additional supernova image is expected to become visible around 2035. In this image, blue represents light at 1.15 and 1.5 microns, green is 2 microns and 2.77 microns, and red is 3.56 and 4.44 microns. When a supernova explodes behind a gravitational lens, its light reaches Earth by several different paths. We can compare these paths to several trains that leave a station at the same time, all traveling at the same speed and bound for the same location. Each train takes a different direct, and because of the differences in trip length and terrain, the trains do not arrive at their destination at the same time. Similarly, gravitationally lensed supernova images appear to astronomers over days, weeks, or even years. By measuring differences in the times that the supernova images appear, we can measure the history of the expansion rate of the universe, known as the Hubble constant, which is a major challenge in cosmology today. The catch is that these multiply image supernova are extremely rare. Fewer than a dozen have been detected until now. Within this small club, the 2016 supernova in MRG M0138, named Requiem, stood out for several reasons. First, it was 10 billion light years distant. Second, the supernova was likely the same type that is used as a standard candle to measure cosmic distances. Third, models predicted that one of the supernova images is so delayed by its path through the extreme gravity of the cluster that it will not appear to us until the mid-2030s. Unfortunately, since Requiem was not discovered until 2019, long after it had faded from view, it was not possible to gather sufficient data to measure the Hubble constant then. Now we have found a second gravitationally lensed supernova within the same galaxy as Requiem, which we call supernova Encore. Encore was discovered serendipitously, and we are now actively following the ongoing supernova with a time-critical director's discretionary program. Using these Webb images, we will measure and confirm the Hubble constant based on this multiply image supernova. Encore is confirmed to be a standard candle or type Ia supernova, making Encore and Requiem by far the most distant pair of standard candle supernova siblings ever discovered. Supernova are normally unpredictable, but in this case we know when and where to look to see the final appearances of Requiem and Encore. Infrared observations around 2035 will catch their last hurrah and deliver a new and precise measurement of the Hubble constant. These observations were taken as part of Webb Director's Discretionary Time Program 6549. Thank you for watching. If you've enjoyed our videos so far, subscribe our channel for there's more to come.